Hi, in this video, we're going to go through a particular case in which all the cash flows are fixed and the discount rate is also fixed. Okay, this is very common in real life. So from previous video, you should be able to calculate such an income stream, right, with all the cash flows at C and a discount rate of R. Okay, we can always write here like C over 1 plus R times C over 1 plus R squared plus C over 1 plus R to the power of 3 up until there are 7 years here, so 1 plus R to the power of 7. Okay, so if you're given specific numbers, you can always work this thing out, but it's quite a fuss. Yeah, we do not want to use the calculator that much, and especially when you have 10 years or 20 years or even 50 years more than that, we're not going to write all this calculations and do the calculations by hand or on the calculator. So is there a way to simplify all this calculation? Okay, so if you can notice, this expression is actually a summation of a geometric series with a common ratio of 1 over 1 plus R. Okay, so if you're not familiar with mathematics in this way, we're going to derive the result for you. Okay, so for example, if I have a geometric series that begins with a number a1, okay, and the second would be a1, let's say, times q here. So the common ratio would be q. And the next term would be a1 q squared. Okay, if I have, for example, t terms of this series, then the last term would be q to the power of t minus 1. Okay, so remember this one counts as well. So if there are t terms, there should be t minus 1 for the last term as the exponential, right? So how do we conclude, or how do we calculate the summation for this expression? Okay, so if we write it as s, then we simply have to multiply this whole expression by the common ratio, which is q. Okay, so I have a1q as my first term and a1q to the power of 2 or squared as my second term, and then a1q to the power of t minus 1, and lastly a1q to the power of t. Okay, now we should calculate s here, so I only need to subtract the first equation from the second one. So I have q minus 1 s is equal to, and you can see these terms will be cancelled. Okay, they'll be cancelled. So you have a1 q to the power of t minus a1. And do a bit of rearranging. We have s is equal to, okay, a1 q to the power of t minus a1, and then q minus 1. Okay, so basically this is the expression of the results of the summation of a geometric series. Okay, so in this case, for our income stream, we can use this technique or use this result to calculate the present value. But notice there's a difference. Okay, so this expression is the summation of s here, and s begins with a1. Okay, so a1 does not have a q term here, so it's different from what we have here. So the first term, or the first cash flow, does not happen at t equals 0, because you won't have to discount the t equals 0 cash flow, right? You only discount what's in the future. So the first term is actually already discounted here. So the first term is c over 1 plus r, okay, which is a bit different from this expression, since it starts with some term that does not have a q inside. So what we're trying to do here is actually get an expression of this one. Okay, so you only have to multiply a q outside of here. Okay, and then we will replace the q with 1 over 1 plus r. Okay, and then we have our final result. Let's show you step by step. Okay, so a1 here would be, or a1q, you can just write c here. Okay, so c and 1 over 1 plus r to the power of t, and minus c, and on the denominator you have 1 over 1 plus r minus 1 here. And remember, we're discounting the whole thing here, yeah? We don't have the cash flow at here, or at this point, right? There's no cash flow here, so we don't discount it here. So we are trying to get this expression instead. So we have another 1 over 1 plus r outside of it. Okay, so the rest is just to simplify this expression. Okay, so on the denominator, you can just write, so 1 minus r. Remember, it's a minus sign, yeah? So here you can collect the terms, which is 1 to the 1 plus r to the power of t minus 1. Okay, and remember the outside is 1 plus r as well. Okay, so if you take this part inside here, and you will cancel these two, and then the 1 minus 1 here is also cancelled, and you're left with the minus r here. Okay, we don't wish to see minus everywhere, so you can just switch the positions of these two terms. So basically, you have your numerator and denominator multiplied by minus 1. So you're switching these two. Okay, and then you will have the final answer here, which is c over r times 1 minus 1 plus r to the power of t. Okay, and this is what we call the annuity formula. Okay, so this is annuity formula. So let's go back to our example here. If I have 7 years, okay, then t equals 7. And if you're given the actual numbers or numerical numbers here, c and r, you just have to plug in the numbers. Okay, so be aware that this only works, okay, this thing only works when certain assumptions are met. And what are those assumptions? Fixed cash flow for each year and a fixed discount rate for each year. Okay, now you have a new way of calculating the annuity. Rather than doing it manually, stage by stage, you can just use the annuity formula instead.